Okay, so let's talk about atomic structure. Let's talk about what an atom's made up of. But first off, let's understand what an atom is. Um, if we took, let me draw a little picture here. This is aluminum foil, and why our aluminum foil is orange, I'm not sure. But let's say we took a piece of aluminum foil and we cut it in half, and we cut that piece in half, and we cut it in half again, and again, and again, and again. And we'd end up with a really tiny piece. And if we had a special scissors that could cut really, really small, we'd come up with a really, really small piece. And when we're not able to cut that piece of matter, and I've talked about matter before in other videos. Matter is anything that has mass and occupies space. It's anything we can see, touch, feel, smell, taste. It's anything that it's everything real. It's anything around us. It's everything we see. I'm made up of matter. You're made up of matter. The computer screen's made up of matter. Um, but when we look at matter and we break it down, the smallest piece of matter is right here, and that's called an atom. An atom, and actually, that's not entirely true because an atom you can break down further, but that's for future videos. But an atom is as small as we can get things, for the most part. Now, an atom, just to give you some perspective here, if I drew a line, if I took my pencil, my number 2 pencil, and I drew a line like this, if we look at not the length, but the width or the diameter of this line, if we look this way at this line, um, in that line there's approximately 5 billion atoms. Like I said, width-wise or height-wise of that line, 5 billion atoms. So you can imagine how small an atom is. Of course, we can't see an atom with the naked eye. What I'm pointing to right here, that's not really the size of an atom. There's probably a couple billion atoms in that little dot. So atoms are very, very small is the point I'm trying to make here. Um, so now we understand what an atom is. Let's look at the structure of an atom. Let me get rid of some of what we have on here. Um, so an atom is made up of 3 parts, and it's made up of protons. And let's draw a couple on here. A couple protons and a couple neutrons. And some electrons. And these are outside like this. So if we look at an atom, it's made up of protons and neutrons in the middle, and this is what makes up what we call the nucleus. And you've heard that before. Nucleus. Okay, so that's our nucleus. Outside of our nucleus, we have electrons. And we have electrons that float around in what we call these orbitals, and I'll make a whole video on that. But this is an atom. This is the basic structure of an atom. This whole thing that we're looking at is an atom. It's protons, neutrons, and electrons. So if we look at each piece, we look at protons, and we look at neutrons, and we look at electrons. They all have a charge, and protons have a positive charge. Neutrons have no charge or a neutral charge, and electrons, of course, have a negative charge. One thing that you probably know, whether you took any type of chemistry or not, is that opposites attract. And because opposites attract, that is why an atom stays together, because it has these negative electrons and these positive protons, and they attract each other, so they have some type of pull toward each other. Well, I'm drawing my arrow the wrong way, but they have some type of pull toward each other, so it keeps the atom together. If you look at the protons and the neutrons of the nucleus and you're wondering how that stays together, nobody's really sure. Nobody's really sure how that works. It's something called the nuclear strong force, but it's not fully understood how the protons and neutrons actually stay together in that core that we call the nucleus. Just to give you a little more of a perspective about of how small we're talking that an atom is. If we look at protons, protons have a mass in grams of 1 point, and let me write this out. Okay, we have 1.672622 times 10 to the negative 24th power. And like I said, that's in grams. So that is the mass of a proton in grams. 1.672622 times 10 to the negative 24. So if I could move my decimal over this way and count 24 and add in a whole bunch of zeros, but I would be off the page. So you get the idea, though. You get how small of a piece of mass we're talking here. So that is for our proton. Our neutron is relatively the same size. It has a mass of, I have 1.674927 times 10 to the negative 24th power, and that's in grams too. So it's about the same size as a proton. If we look at electrons, electrons have a mass of 9.109, 328 times 10 to the negative 28th power in grams. So, I mean, don't be concerned with these numbers. You don't need to memorize these or anything, not at this point at least. But just understand how small we're talking. 9.1093, I can't read my writing, but 328, I think, times 10 to the negative 28th power, and that's in grams. Of course, that's so tiny, and let me give you a little perspective here how tiny that is. When we look at the atomic mass unit, and maybe you've heard that before, it might be a new term to you, but atomic mass units, what that's looking at is the mass, not the weight, but the mass of that atom, and it calculates the mass by taking into account the mass of the protons and the neutrons. And it doesn't even look at the electrons because the electrons are so tiny. They're so tiny that relatively it doesn't even matter. It doesn't matter it doesn't pay to count the electrons. It's not going to change our number very much. So we only look at the protons and the neutrons when we look at the mass of an atom. Okay, so I think I got the point across that atoms are really small. The one last thing that I want to make clear to you is this is our atom. When we look, well, we don't actually see an atom, but when we do look at an atom under a microscope, of course, let me get some of this out of the way, and then I'll draw it here. Okay, so the nucleus of that atom, just to give you again a perspective here, if we looked at a baseball stadium, and I'm not sure I can draw a baseball stadium, but let me try. So let's say that's our baseball stadium, and I'm talking like a big baseball stadium, like Miller Park. Okay, pretty big place, right? And if we took a pea, like a pea that you would eat, that's a pea. This would represent our nucleus, and this entire stadium would be the size of our whole atom. So that would mean that we would have electrons that would be somewhere outside here, and they're in their orbitals, and like I said, I'll get into that in a different video. But I mean that is how small the nucleus is, proportionally when we look at an atom. So the point I'm trying to make is everything is made up of atoms, and when we're looking at things, we see things like they're solid. Like if you look at your desk or you look at a piece of wood that's solid, but in reality, 99.999, and that I'm sure that number goes on for a while, percent of things aren't actually there. It's not physical mass that's there. It's the electrons that are floating around, and electrons move so fast that it gives us this visual like something is there. So it makes it look like it's there. And then the other question is, well, okay, I understand that it makes it look like it's there, but if it's not really there, why can't I put my hand through it? Well, one answer to that is because it's so small. Atoms are so small, of course you can't put anything through them. And the other part of that answer is the electrons are moving so fast, nothing would be able to get in there. It's the electrons move too fast that they're occupying that space, or they're giving us the image that they are. So, if you think about it, if you just think about the basic structure of an atom, it's really mind blowing, and it's really kind of interesting. So that if that doesn't interest you into chemistry, then I don't know what will, because I think that's just fascinating to think about that the 99.999 repeating percent of something isn't actually there. It's not actual mass. So that's the basic structure of an atom, though. Protons, neutrons, electrons. Protons and neutrons make up our nucleus. Electrons are floating around outside. I think the next video I'm going to do is talking about the orbitals with electrons and how we find them, and maybe I'll talk about wave functions and some of that stuff.